Hello everyone, welcome back. In the first part of the class of electromagnetism, we have discussed up to the various topics like the magnetic fields, its relation with electric fields and all. And today the class we will start with finding the detections from electric field for some state current conductor, then for a current carrying loop and for solenoid and like that. And after that, we'll be discussing some laws like Fleming's left-hand law, Fleming's right-hand thumb rule, and using those laws, what are the devices that uses that laws to work properly, like electric motor, which works on the uh, principle of effects of force on a magnetic field, and like electric generator, which works on the principle that has been discussed in the last day, that is electromagnetic induction. And after discussing all these kind of things, we'll be discussing about some points regarding the domestic electric circuits, that are the household electric circuits. What are the basic kinds of components in an household electric circuits, about the as what are the and one thing, while discussing the electric generator, we'll be also discussing about ACs and DCs, the two types of current, basically AC current and DC current. What our house are provided with AC current, what is the who is maintaining the potential difference between our houses, like as we know that while flowing a current, potential difference is needed. Who is meant? What is the potential difference that is required? How is our home connect? All the appliances in our homes are connected. So let's see. Okay. Magnetic field in a straight current carrying conductor. It was experimentally observed that the magnetic field around a straight current carrying conductor forms some shapes like concentric circles. It means in the last slides it's already clear that a current carrying conductor behaves like a magnet. Now the magnetic field around this conductor will be like some concentric circles. Now what will be the direction of the magnetic field that has been induced? The direction for finding the rule for finding this direction of the magnetic field was then given by Fleming, which is something like this. The magnetic field around a straight conductor, using right hand thumb rule, which shows this arrow shows the flow of current in the straight carrying conductor, and this is the direction of the magnetic field. Means if current is growing in this direction, the curl finger of your hand will give the direction of the magnetic field, provided that the thumb is pointing the direction of the flow of current. It means magnetic field around the straight conductor is something like that. This is the famous right hand thumb rule. It means if current is going in this direction, the magnetic field induced will be in this direction. If the direction of current is reversed, then the magnetic field is also reversed. Now we have seen the magnetic field lines produced by a straight current carrying conductor. This diagram is showing a magnetic field lines produced by a current carrying circular loop. This is a circular loop. These are the kind of magnetic fields that are induced while a current carrying circular loop carries a current, behaves like a magnet. And this is the magnetic field that is shown that is produced during while a solenoid behaves like a magnet, while a current is passed through a solenoid. A solenoid is basically number of turns in a coil that is connected with a potential difference. Then this behaves like a magnet, and the magnetic field lines is quite similar to a bar magnet. So it's quite said that this current carrying solenoid, the field produced by a current carrying solenoid is almost same as the field produced by a bar magnet. So this is completely behaves as a bar magnet. So a current carrying solenoid is sometimes says to behave like a bar magnet. Here onwards, we are heading towards the topic force on a current carrying conductor in a magnetic field. We have already known that a current carrying conductor behaves as a magnet. So that magnet has a magnetic field. Now, what will be the effect of that magnetic field on the conductor, or any magnetic field, or the effect of any magnetic field on a current carrying conductor? So first, a French scientist named Ampere, he observed something through some experiments, and suggested that this current, if that a that the magnet must also exert an equal and opposite force on the current carrying conductor. Now we can actually understand this statement through an activity. Means, if a circuit is placed within soft that is, if a circuit is made with a movable conductor in it, so that the conductor can have a free choice to move, and a magnetic field is applied over it, when current will be flowing through it, it is observed that under the influence of this magnetic field, this conductor is actually gets displaced, while the flow of current is in one direction, the movement is also in one direction. If the flow of current changes, the direction of flow of current changes, the movement also changes. If the polarity of the magnet is also opposite, it means if the north pole is changed by south pole and the south pole by north pole, then the magnetic field get reversed. In that case also, the movements also get reversed. So it's for sure that a current carrying conductor, whenever placed in a magnetic field, it actually force is applied on it. Whenever a current carrying conductor is placed over in a magnetic field, it experiences a force. This force, so now as we know that force is a vector quantity, this force, so it needs a magnitude as well as direction. So as it is moving, so in which direction will the force be experienced? Now considering this, we have a law that is famous, Fleming's left hand rule, which says that considering the magnetic field and the current both perpendicular to each other, if we consider that this magnetic field and the electric field, or the current, sorry, not electric field, if the magnetic field and the current is considered to be perpendicular to one another, then the force that will be experienced by the conductor will be perpendicular to both the magnetic field and the current. It means both the three of these components will be mutually perpendicular to each other. So this is the famous Fleming's left hand rule. It's the forefinger pointing the direction of the magnetic field, the middle finger pointing the direction of the current flowing through the circuit, then this thumb will show the direction of the force experienced by the conductor placed in a magnetic field. Now based upon this concept that a current carrying conductor in a magnetic field experiences force, we will get to know about a device called electric motor. An electric motor is basically a device that is used in most of our daily life experiences, which is actually a rotating device which converts electrical energy to mechanical energy. Now we are providing there is a battery connected to the external circuit, so definitely we are providing an electric energy to the circuit, to the ultimate system, and it will finally provide a mechanical output to it. First, we have to know about the construction of this electric motor. This electric motor is nothing but a rectangular coil which is connected to two brushes and finally to a commutator. Commutator is basically a device which actually reverses the direction of flow of current. Now, and this circular loop is placed inside a magnetic field. Suppose these are two magnets. This is suppose north pole, we are taking this as north pole and this is south pole, and then the circular loop is such place that if current flows through these two directions, then these two edges will be, the current through these two edges will be perpendicular to the magnetic field, because we have in the earlier Fleming's left hand rule we have considered that the magnetic field and the magnetic field and the direction of flow of current should be perpendicular to each other. So when current will flow through one direction, then it will be found by using Fleming's left hand rule that one end of this will experience a force downwards and another end will be experiencing force upwards, which will give it a clockwise rotation. After half rotation, what will happen? These two connected brushes will be reversed. These two connected brushes will be reversed. So what will happen it again? That here comes the function of the commutator. The commutator will reverse the direction of flow of current again. So if the direction of flow of current changes, then what will happen? Then this rotation, well, it was experiencing a downward force, this was experiencing upward force. After half rotation, this will be coming here and this will be going here. So this one will now face a upward force, this end will face a downward force, which ultimately will lead to a situation that this motor will be constantly rotating and rotating. If we connect an axle through this setup, then this axle will also be moving, and any kind of fans or any kinds of blades that are mostly used in our day-to-day life, those are appliances which needs a continuous rotating kind of things that are actually connected through this kind of motors. The working is shown in the next figure, that here this north pole and this is south pole. So what is happening? An external circuit is connected to an axle. This is the axle and this is the current carrying loop. So what's happening? When we are applying the electric field, we are applying the potential difference, current is flowing through it. This direction of current is perpendicular to the direction of the two sides, this side and this side. This is perpendicular to flow of this side. So these two sides will experience a force. One will be inward and another will be upward. So both these forces will be forming a couple and they will be doing a clockwise or anti-clockwise rotation depending on the first applied depending on the first direction of the electric current. So the important conclusions that the important points that to be noted while studying this electric motor is that electric motor is a device which converts electrical energy to mechanical energy. Second thing is that while studying this electric motor, Fleming's left hand rule is used. And one more thing for students, that the function of difference part, what is the that I had told you that what are the function of this commutator? It reverses the direction of the flow of current. What is the function of the brushes? What are the function of these rings? Why these rings are used? Try to find out these answers. Now, as we have discussed one kind of rotating device, we are moving towards another kind of rotating device, that is electric generator, which is also in where is also magnetic field applied. But the thing is, the electric motor was based on the principle that a current carrying conductor experiences a force inside a magnetic field. But this electric generator is based on the principle of electromagnetic induction. As in the last discussions we have discussed that electromagnetic induction means that whenever there is a relative motion between the magnetic field and the conductor in a magnetic field, then a current is induced, actually a potential difference is induced, and then a current flows through the circuit. So this is a similar kind of construction of an electric generator, where again an circular coil is placed, but here two rings with two brushes are connected with no external source, just a galvanometer is connected here, so to detect the presence of electric current through this external circuit. Now what happens in the last electric motor, there was no the axle. We were providing an electric potential difference and current through a circuit that was rotating automatically because it was experiencing a force. But here, as there is no voltage, we will mechanically, an electric generator basically converts a mechanical energy to electrical energies. So we have to, now this axle, we have to move this axle because so that this coil can be rotated. While we will rotate this angle, then what will happen? Following the law of electromagnetic induction, there will be a or that relative motion between a conductor and a magnetic field. Then a current will be induced through this circuit. See, in this diagram you can see that while, so you can see that if we move this axle, this circular coil, this circular loop will move with it. This circular coil will start rotating. Now as it will start rotating, this externally connected circuit will there will be a current flowing through this external circuit. But here is another deep thing that we must know, that we are moving this axle first. If we are moving, the first half will be moved, then there will be a flow of current in one direction. See, this galvanometer is showing a deflection in one direction, but whenever we are moving the second part, then what happens? Suppose this end was experienced so when it was this end is moving here to here, then what happens? Current is flowing through one directional, and then this end is again under the influence of this magnetic field, so the direction of the current will be changing. So in an electric generator, what happens, that the current produced, it changes its direction frequently. This type of current, which is actually which actually changes its polarity, means the direction of flow of current at an interval of time, is known as AC current, means alternating current. There are two types of electric current. One is direct DC current, one another is AC current. This kind of construction will produce AC current in the circuit, because whenever this loop is moving, first half the current will be in one direction. This direction of the current induced EMF also can be found by using Fleming's hand rules. So this in first half, the direction of current will be in one direction. In second half, when the axle is again moving, the direction of current is opposite. So in the current, electric generator is producing an AC current. So here important points are that based on this electric generator is based on the principle of electromagnetic induction. This converts mechanical energy, or uses mechanical energy to produce electricity. Fleming's right hand rule is applied, both AC and DC. Now I have said that this kind of generator which produces AC current. What is a DC generator? Now if we this AC generator can be somehow converted into a DC generator. How? DC means there will be a steady flow of electric current through the circuit, but here it is not one directional or steady flow of current. Here both the direction is it's at a time interval changing, but in DC current the polarity does not change. It's a one directional flow current. So if we use commutator over here, then and slip rings over here, by using that kind of arrangement, a DC AC generator can be converted into a DC generator. Moving toward the last topic of your chapter, that is domestic electric circuit. Domestic means we are our household electric circuits. We have studied the last two chapters, electricity and electromagnetism. Now it's time to study that whatever the current that is in our in our houses, what kind of electricity that we have, what are these is the electric circuit. As you know that a complete path is required to maintain a flow of electric current through a circuit. So we have to study about the electric connections and combinations that forming a circuit in our house. Basically, our house have three important things to be noted down. While a connection is made in your house, three wires are very much important. One is live wire, which is actually giving the, you can say this is the positive end of the while we are applying this potential difference in a circuit. We know that a potential difference is applied, maintaining a higher and a lower voltage, lower potential difference. So now this red wire, this is called as live wire, which is actually you can like somewhere say this is similar to the positive end of a battery. This neutral wire, this is you can be said as a negative end of a battery. This is maintaining a constant 220 voltage in our household. Now this 220 voltage is the voltage that is required for operating, that is required for operations for most of our electrical appliances. Now here is a question comes, if all the appliances works on 220 voltage, how is it that all the appliances get 220 voltage in our house? This is because remember that the appliances in our house is connected in parallel combination. Remember we have learned in that there are two kind of combinations that are made in a resistors. One is series combination, another is parallel combination. In parallel combination, the potential difference is not divided, rather the current. So in case that in our household circuits, all the appliances are connected parallelly, so that each appliances get a equal potential difference across it. So three important components. One is live wire, which is actually, you can say, the positive terminal of a battery. And second is neutral, is to some extent the negative side of a battery. This earth wire, this is a very important thing. This is a grounding wire. It is actually allowing to be grounded. This is this live wire, or the positive, is actually by this red wire is insulated wire. This black one is neutral. This green one, this insulated, that I was talking, that this is very much important mainly for those appliances which has a metal body, because sometimes what happens, there is a leakage inside the metal construction of a appliance or something, so there is a possibility of getting electric shock. These grounding will what it happens, that the basic mechanism is that it balances the flow of current through it. So if there is any misconnections or any kind of chances of getting shock through that metal kind of appliances, this wire is first connected. This wire reduces the chance, this actually minimizes the chance of getting shock, because through this wire the all the current will be flown through the earth. This grounding, this earth wire is connected deep underground to all the circuits in an household. If you observe, you can see that there is an earthing connection in every one of our homes, connected to the various appliances, either through some main circuit or like that. So this grounding is very much essential. Grounding is always important for an electric circuit. So the important points in here are that there are three kind of basic connections, that live, neutral and earth wires. This is, you can say, the positive, the negative, and this earth wire is actually for what? For those for minimizing the chances of getting electric shock. And fuse, yes, I forgot that fuse. Fuse is a very important, in all every connections of our house, you can say there is a fuse. A fuse is nothing but a path, a bridge between this source of connection and our household appliances. Now this fuse works on the concept of heating effect of electric current. Sometimes it means a fuse is nothing but a very, very thin conductor which will not allow. It means let us take an example. Suppose there is a bridge. It can carry only a minimum amount of load. If more than that kind of load is over the bridge falls down or breaks. This fuse is a kind of bridge over the source connection and our appliances. If sometimes any overloading on short circuit happens inside our circuits or something like that, and so for that, if more amount of current tries to flow through our circuit, this fuse, if properly planted, if it's properly planned and used, then it will break down, because more current will generate more amount of heat in it. So and it's measured and implemented in that way that it will ultimately hold a certain amount of heating effect. So it will break down and it will save all the other appliances from getting excessive potential difference, which will actually harm the appliances in our house. Moving towards a very interesting observation of phenomena, that in our as in the last video also I have shown you a phenomena. This is a phenomena that is in a 3-pin used in our daily to daily life, one pin of a socket is, or in a pin or a socket is bigger. What is the reason that one pin is bigger in a 3-pin? This is because that as I have told you, that this earthware is very much important for those appliances mainly with metal body, so that if there is any leakage, the chances of getting short can be minimized through as the excessive flow of electron through these ways gone under the ground, because it is taken that the earth is potential, this earth can hold a large amount of potential electrons. So all the this earth is taken as huge negative to things. So if there is any kind of live or positive charged excess or excessive in any kind of appliances, so it will go through this earthware to the ground. Now why is this 3-pin in 3-pin one pin is made bigger than the others? This is because whenever in a connection, if there is any leakage in a metallic body or something like that, this is actually in a 3-pin, one is live, one is neutral, one is this one is live, neutral, and this pin is for grounding pin. The grounding pin is made thicker and bigger because the grounding pin should be connected to the server first, to the appliance circuit first, because if there is any chance of leakage in the inside the body of the appliance, then the current will flow through their grounding and will go to the ground. So it will cancel out the chances of getting shocked through that appliances. Another technical cause is that we know that resistance is directly proportional to length and inversely proportional to area. It means if length is increased, then R will also increase, and if A is increased, then R will decrease. Means here is a limited chance that we can increase the length, but the area cross-sectional area is made to some extent bigger because it will reduce the resistance through this pin. So if the resistance is less, so the current will flow easily through that path, and through the grounding it will minimize the chances of getting shocked. So up to this was a primary discussion, a very short and brief discussion regarding the 2 chapters, electricity and magnetism. We will thank you everyone, and we will try to do some maths on these chapters in the next video.